All right. The definition of a limit. Now, the formal definition of a limit is let f be a function on an open interval, containing c, parentheses, except possibly at c, and let L be a real number. The statement, the limit as x approaches c of f of x equals L means that for each epsilon greater than 0, there exists a delta greater than 0 such that if 0 is greater than the absolute value of x minus c, so the difference of x and c is less than delta, then f of x minus L is less than epsilon. Now, what this means, essentially, when you put it on a graph or apply it, it essentially means that with any function, right, there is a point, right, C, and there is another, and there's a y to this point, L, and as x approaches C, x, or the y, will approach L. This bottom section is meant to indicate that of closeness. This is going to, as we approach C, we're going to continue to get closer and closer and closer to L. So if L doesn't even exist, right, as we approach C, as we get infinitely close to C, we're going to get infinitely close to L. We're going to get very close. It isn't necessarily describing that C is going to be, that if you plug in C, it's going to be equal to L. It's saying that the closer we get to C, we're going to approach very close to L. This is why if you have a function that looks a little bit like this, where there is a defined point for C, right? And there's an L to that point. As we get infinitely close from this side, it does not equal what we do get when we get infinitely close from this side. So it's concerned with how the function changes as you get closer and closer, even to the smallest decimal.